Hi, welcome to week 2, lecture 1, part 1 of 3 for introduction to symbolic logic. So up to now we've covered a fair amount of informal ideas, including what an argument is, deductive validity, deductive soundness. We covered logical truth, logical falsity. So these are all the things that you should already have under your belt by now. What we're going to do today is the first part of an introduction to the actual symbolic system that we're going to use. And this system we call SL, or symbolic logic for short. And symbolic logic is going to be a formal system. It's a formal language. So natural languages like English and German, they aren't taken to be what we were going to call formal languages. They're natural, right? They're the things that you learn without having to study formally. What we're going to study is this formal language. So in fact, what we're going to do is we're going to invent it. So we're going to be very explicit about what symbols we're allowed to use and what the syntax of this language is, and then also what the semantics for this language is. So SL, which you might think of actually, it's a symbolic logic, a symbolic language. I think that's what the text calls it, symbolic language. Okay, what this language basically does is its basic units are sentences. So if you remember, the things that we've been interested in so far are what we've called declarative sentences, sentences that can be true or false. So the basic unit of SL is going to be the sentence. And remember, these were declarative sentences. So, and declarative sentences are the sentences that can be true or false. Okay, so those are our basic units. And what we're going to be interested in is how we can combine these basic units into more complex structures. So the sentence is going to be it's going to be atomic, right? So this basic unit, or what we might also call atoms, are the sentences, and then the more complex sentences that we're going to build out of these basic units are called molecules. So you might call them complex, I'm going to put square quotes here, complex sentences, but they're built out of the atoms. Okay, but we're not going to combine them in any old way in which we do in English. What we're going to be interested in is a particular kind of connective that's going to be what we're going to call a truth-functional connective. So let's go through some examples of connectives in natural language. We have ones like and, but, although, possible that, it is possible that, it is not the case that, and let's think of one more. Or is always another great example. So what I mean is we can combine two sentences into a more complex sentence. So we can say things like, John is at the store, and we can put a period there. And then we can say, Andy is hiding in the basement. So I can take these two sentences, John is at the store and Mandy is hiding in the basement, and we can make a new sentence, right? So here we have two sentences, but I can turn this into a new sentence. So I can say things like, John is at the store and Mandy is hiding in the basement. But I could also replace this and with or and get a new sentence. And I can also use the connective although and still get a new sentence. I could also use the connective but. John is at the store, but Mandy is hiding in the basement. Now, just adding in any connective might not make the sentence make sense. I mean, there doesn't seem to, unless you think that there's some kind of connection between Mandy hiding in the basement and John being at the store, some connectives will make more sense than others. The ones that we're interested in are going to be connectives like and the reason why is because they connect sentences in virtue of the truth values of the sentences. So these are going to be what we call truth functional connectives. These are the links between sentences that look only at the So what these connections do is they're only interested in the truth values of the atomic sentences or of the smaller sentences. So if we look at John is at the store and John is at the store and Mandy is hiding in the basement. If we compare that to the sentence, let's do this. John is at the store or Mandy is hiding in the basement. These sentences mean two different things. In this first sentence, John is at the store and Mandy is hiding in the basement. What this connective is doing here is saying, okay, this whole sentence is true as long as the first part of the sentence is true and the second part of the sentence is true. And John is at the store or Mandy is hiding in the basement, what this connective is doing here, or is saying this whole sentence is true as long as one of these parts is true. So these are going to be the kinds of connectives that we're interested in, these truth functional connectives. And we're going to define one formally and go over some examples of what we're going to call conjunction. Okay. And we're going to use the symbol, we're going to use the ampersand symbol to distinguish it from the English sentence and. So and in English sometimes is a truth functional connective, but other times it's not. So in order to make sure that we distinguish the symbol in our formal language in SL from the natural language connective and, we're going to introduce a new symbol, which we here have as ampersand. And this is a truth functional connective. Okay, so let's give some rules for this symbol, and then we'll look at what kind of English, whether or not it maps onto an English connective. So I'm going to introduce symbols here, P and Q. So we can read it in English as and, but think when we say P and Q, what we mean is this ampersand symbol. Okay, and these letters here, these capital Roman letters, these are abbreviations for an entire sentence. So P could stand for John is at the store. And Q can stand for Mandy is hiding in the basement. The idea here is that these Roman symbols stand for an entire sentence unit. So these you can think of as our atoms. And ampersand here is our connective. So we're connecting this one sentence with this other sentence. And we're going to have some rules about it. So I'm going to introduce some other notation here. This is a little bit clearer in the book. So what I'm doing here is I'm going to write out a truth table. So what we have is, since this is what's called a binary connective, right? So it's a binary connective because it takes in two parts. And given that we have two different kinds of truth values, right? A sentence can either be true or false. That's it. So if you have one sentence, the number of different possibilities that you can have is 2 in terms of whether or not it can be true or false. But if you have 2 sentences, the number of combinations that you can have is 4, right? Because we can have a scenario where P is true, and actually what I should do is tab these. Let's do that. Okay, so we have a scenario where P could be true and a scenario where Q could be true. But then we can also have a scenario where P is true and Q is false. There we go. We can also have a scenario where P is false and Q is true. And lastly, we can have a scenario where P is false and Q is false. So these four possibilities exhaust all the possible combinations of the sentences being true or false, being combined with one another. So now what we need is a way of defining the rules for when we want the complex sentence to be true or false, according to when the components are false. So the reason why we call this truth functional is because the truth of the whole sentence is only dependent on the truth of the atomic sentences. So the way we're going to do this for conjunction is we're going to say that P and Q is true whenever both P and Q are true, right? So in the scenario where both P and Q happen to be true, we're going to say that the complex sentence is true as well. When P is true and Q is false, we're going to say that the whole sentence then is false. Similarly for the case when P is false but Q is true, we're going to say that P and Q is false in this case. And for our last scenario, when both of them are false, we're going to say that ampersand is false here. So I'm just giving a formal definition of this, and we're going to look at this in a little bit more detail to see how it maps on to English. But we're going to do that a little bit later on. So just to recap what we've done here for this lesson, we've introduced the notion of a symbolic language that we're going to use to advance our studies of logic. We start with the basic units, which are sentences, so things that can be true or false. And the connectives that we're now interested in, or we're going to introduce connectives to provide a more expressive power to our system. And the kinds of connectives that we're interested in are the truth functional connectives. So these are connectives that look at the atomic sentences and all they care about are the actual truth values. And here we introduced one such connective that we're going to study, which is we've called conjunction. The symbol for conjunction is ampersand, and we've gone over the truth table for conjunction. So we said that P and Q, this complex sentence, or this molecular sentence, is true as long as both of the atoms are true. If both the atoms are not true, so if Q is ever false, or if P is ever false, or both of them are false, then the complex sentence is false as well. Okay, that completes our lesson. If you have any questions or comments, please feel free to add them.